And so we thought it would be a very good speaker to be able to explain students how it is to create his company. And also, he has a very nice application in mind. So, Henri.
So, hello everyone. So, my name is Henri. So, as Marie-Paul introduced me, I created a company in 3D animation. I think I'm about the same age as you, more or less. So, I'm going to explain how I got into creating a company on 3D animation. And so, if you want to do the same at some point, you can ask me a question. So, to introduce myself, I created Kinetix 2 years ago now, in 2020. And I'm a co-founder and CTO. I have another co-founder who is more specialized in business. So he really runs the how to raise funds, how to target a market, everything. And I deal with the R&D and development, etc. So we're going to talk again about the metaverse. So to introduce myself a bit more and to explain why I got into creating this company. So yeah, I made my studies in Central, where I specialized myself in deep learning, and especially generative deep learning, like how to generate images, sound, video, 3D, etc. I began to do research in Dynamics, up left, who was doing a solution of facial motion capture. So with a video, you had to, facial video, reconstruct the facial animation of someone. So I did that for 6 months. Then I entered the real working into Dassault system in research in deep learning also, where I had to, from drawings of objects with deep learning, create 3D models of it with deep generative networks. So that was for my research in deep learning, and then I wanted to go into the industry, the real industry in some way, and I entered Shift Technology, which is like a data science, insurance data science. Well, it was like the most boring experience I've ever had. It was like how you, someone make a claim on insurance, and I had to use data science to say like, oh, is a fraud or is not a fraud, to like make earn to AXA France or any insurance company some money. So it was like working for the bad guys, and more of it not that well paid and very boring. So 1 year after, I said no, it's not possible. I won't spend 40 years doing those sort of things. So I wanted to make my own projects, and to do this, I think I saw like two options. Either I went into a PhD to like really work on something that I was passionate about, or create a company. I was afraid of the PhD because I knew I can get bored easily. So I didn't want like to do 1 year of PhD and then get bored. I hope none of you are in this case. But like I was scared of it. I was scared of the PhD because of it. So I wanted to, I thought like, I'm going to create a company. So why 3D animation? I guess like most of you, I'm passionate about video games. I do a lot of gamings. Less and less now, but a lot of gaming. So I wanted to create a company that was fun because I was so bored with insurance. I wanted to do like the complete opposite of that. So with my co-founder, we said he's passionate about gaming too. And we thought, yeah, okay, we're going to create a company in something we're passionate about, the gaming. So how did we start to do it? We didn't come up with the idea and develop it and then present it to people. We just began it with calling as much people as we could, like every gaming studio, every esport federation, everything in this field, asking like, what's your biggest problem? And what could we solve? And more, they were talking to us about 3D animation because it's a very time-consuming field, 3D animation. Like most of the studios, like Ubisoft was telling, for 1 minute of animation, it can take up to three weeks or several months if it's for AAA games. So we come up with the idea of using deep learning, using generative deep learning to help create 3D animation and help studios like Ubisoft to create more easily video games. So the basic ideas was we're going to create a software where anyone can provide a video, and we're going to do some AI motion capture on it, and we're going to give them the animation, the resulting animation, and they're going to use it in video games. So we got up with that. We created a MVP, so a first version of the product in 1-2 months, something like that, with existing papers, thanks to research guys like you. So, and after 1-2 months, we're speaking to Ubisoft, Epic Games, and a lot of video games companies, and they're all telling us like it's not the quality is not good enough, and it's never going to be good enough with motion capture like that. So we hesitated about like giving up because like everybody was telling us it's not going to work. So we had to think about shifting our philosophy. Since the AAA games were not going to be accessible to us, we're going to target some people who need like less quality animation, and that's where we got into the metaverse. I'm going to explain a bit more why the metaverse, but mostly because in the metaverse it's a UGC field, user-generated content. So there's a lot of people who need less quality animation than Ubisoft for AAA games. So we thought maybe for these people, a lower quality animation software can be very useful. So yeah, that's how in a very short we got into the company. I'm going to present a bit more later what we do in the company. But yeah, about creating a company, I did it without a PhD, but I have a lot of friends who created a company just after the PhD. It's usually more, it's usually better, actually. So if you have if you want any advice, if you want anything about creating a company, don't hesitate to come talk to me afterward. So what I'm going to talk about is firstly, what is the metaverse? I know we had a little presentation of it this morning. What is the metaverse? Kinetix. So why Kinetix got into a metaverse and why it has something to propose for it. And finally, a bit slightly more technical, what are the technology we are working on, because we actively do research, and why are these useful in the metaverse. So to begin with the metaverse, a little definition. It's a long sentence, but as Matthew Ball described it, it is an expansive network of persistent real-time rendered 3D world and simulations that support continuity of identity, object, history, payments, and can be experienced synchronously by an effectively unlimited number of users. It's quite complicated. There's like a lot of definition of the metaverse. The one I prefer is just like a 3D world where you can have social experiences with your friends, and on the internet, of course. So it doesn't have to be VR, AR, or XR, or anything at all. It's just some 3D world. Like, to me, for example, World of Warcraft could be considered as a metaverse 20 years ago. Second Life, even Habbo Hotel, for those who remember this thing. So, and the most important thing of it is that in the metaverse, there is the universe which is created, like for example by Fortnite or by Roblox, and then most of what's in the metaverse is created by users. It's a UGC experience, a metaverse. Something like YouTube, for example, YouTube doesn't create videos, it just creates the software, and then users create experiences for other users. And metaverse is just like that. It's a 3D world where people are going to create some experience, some games for other users, and they're going to earn money or not with creating this. But such as YouTube, there is a lot of money created in creating some experiences, some 3D experiences, and by people who don't know a lot about 3D. They are not 3D animators, they are not 3D specialists. So there are a lot of people in the metaverse who need some tools to be able to create more easily 3D content, 3D animation, 3D avatars, 3D objects, whatever you want. So just to give you a number, and since Meta announced he was heavily going into the metaverse, Bloomberg stated that the metaverse by 2030 is going to be nearly 700 billion market size. So I guess you're not very much into market sizing like I do, but it's huge for a market. It's really like incredibly huge, and it's going to be it's growing and growing. And to tackle some idea about people who think like metaverse is something of the future, I just want to show this and saying like there are a lot right now people playing in the metaverse. For example, Roblox, which is the biggest metaverse, and which is like ugly as hell, as you can see on the right. So it doesn't have to be like beautiful. It's just 3D world, so it can be ugly, and that's okay. And for example, Roblox is 50 million daily users, which is like incredible. I think it's the fourth biggest video games played in the world, and it's a metaverse. So there are a crazy amount of people every day playing the metaverse. Like in total, it's something like 100 million daily users in the metaverse who are doing some experiences created by other people, just like you have millions of people, hundreds of millions of people every day watching YouTube, watching YouTube videos created by other people. So there are quite a list of the biggest metaverse, but not complete at all, of course. And yeah, for the Minecraft also is considered as a metaverse more and more. Fortnite, I don't really know. One answer would be like on Roblox, on Minecraft, it's much easier for everyone to create content because if you take AAA games or a very realistic metaverse, like nearly nobody will be able to create something in it because it's too complicated, it costs too much money, and it's exactly what the guy this morning, I don't remember his name, was saying. He's creating some high-end characters, which is incredible, but not everybody can do that. On the metaverse, everybody must be able to create some content for it, so that explains to me why Roblox or Minecraft are much more popular as metaverse. So yeah, and the main thing about I hope you will create a company in the metaverse. Everything is left to do in the metaverse, from the infrastructure of how we can connect to it, to the human interface, how it's going to be decentralized. There's a lot of debate of is the metaverse going to be Web 2 or Web 3? I will come back to it. The creator economy, if it's Web 3, how do we pay the creators in it? Etc., etc. And also the content creation, how the content will be created in the metaverse, since it's mostly UGC. So as I said, there is a huge deal about the metaverse will be Web 2 or Web 3. Right now, the biggest metaverse, such as Roblox, are Web 2 based. So it's a centralized economy where Roblox is earning like 90% of the money created by its users. And there are more and more Web 3 based metaverse who are creating, and there is a huge hype in them. But they don't have much users for now, so it's a real debate. Of course, Web 3 allows much more things. Like there are going to be some real objects detained in the metaverse. You're going to be able to have NFTs in the metaverse, having some clothes in the metaverse that really belongs to you. So there can be some economy of branding in the metaverse from people from Nike, for example, or Adidas who bought some place in the metaverse. So there's going to be some huge thing in the Web 3, but for now, metaverse is mostly Web 2. So yeah, that was a very quick explanation of the metaverse. So don't hesitate if you have any question or remarks on the metaverse. It's a huge field right now. Right now, I'm going to speak a bit more about Kinetix. So what we're going to do ourselves in the metaverse. So a little demo. Up. A very little demo, not to take too much time. So the base idea is we want everyone to be able to create 3D animation in the metaverse without having any idea of how to create some 3D animation. So as I said, the first feature we had and we still have is you can bring a video that either you make yourself, either you take from YouTube, you put it in our website, and we produce for you the 3D animation copying the motion out of the video. And then you can, we also have a library of 3D characters, so you can retarget, use the animation onto your target character. We also have a library of animation, so you can drag and drop some animation in the library and add another character, drag and drop the character, put the animation on it, and very easily create a scene with drag and drop philosophy in our tool. So just here to present a little bit of the team. So right now we raised funds last year, so we are something like 40 something. Mostly R&D, deep learning R&D, and platform, so developers, front end and back end. So yeah, 12 in R&D. We have 2 doctors and someone starting a PhD in 3D animation right now. And so developers to create the platform. Some business people, of course, some 3D animators, obviously, because we need to create an animation library, and we need some professionals that teach us what is 3D animation, actually, etc. So why do we think animation is going to be something of the future? You can forget about the hieroglyph. It was to make serious. More and more, we saw like a way of expressing yourself has shifted and more quickly in the past, from emojis to emoticons to memoji. And we think that in the future, in the metaverse, the equivalent of emoji, emoticons, and whatever is going to be 3D animation. You're going to be in the metaverse, and you're going to express yourself directly by 3D animation, either directly with your webcam, either by just as you could click on a memoji, you could click on a 3D animation and express yourself like that. But as a lot of people, we strongly believe that it's going to be the way of expressing yourself in the metaverse and in the future. So yeah, to a bit more about the 3 different things we do in Kinetix. So as I said, the first thing is the creator tool. So our tool is to be able to for everyone to be able to create a 3D animation. So you can see here. So for example, the video that was taken, the animation that is automatically created, the timeline of the animation. So this one was the animation created, and then you can choose animation from a library, drag and drop it here and here, and it's just going to play the animation from the video first, and then animation from libraries, and you can play very easily with it. Also, we do some minting, mint NFTs, also to make some like marketing and everything. But we're gonna partner with celebrities such as, for those who know, Steve Aoki and Snoop Dogg, to create an NFT collection of them, and to be able to just sell them on the metaverse. Snoop Dogg is very into the metaverse. They already like sold Snoop Dogg collections of his avatar in the metaverse. And also, we're creating a game engine plugin for everyone to be able, in Unity or Unreal, to create an animation and directly put it in their video games. So yeah, this, for example, is one of our biggest projects right now, is to be plugged into the metaverse. And like in the metaverse, you would use this self-expression wheel to just click on animation very easily and play the animation into the metaverse. So right now, that's our biggest goal, is to make some deals with metaverses to implement this solution, which is ours, into their games. We've also created a dance competition games in Roblox 3 weeks ago. We got a bit more than 200,000 gamers. I didn't expect that at all. And fight games and virtual concert, we didn't do it yet. But for the why do we say Fortnite is the metaverse? For example, they hosted the biggest concert 2 years ago. I think that was like 70 million people real time watching. I don't remember the name of the guy, but watching a concert in Fortnite. And Epic has more and more this strategy of like turning this TPS game into a metaverse where everybody can play. I think Fortnite is the biggest played game right now. So yeah, that's the goals we have, is to, as I said, make maximum amount of partnerships with the metaverse. So right now we partnered with the Sandbox, the Decentraland, don't remember this name, and Spatial, and celebrities. And also like a Web 2 metaverses too. So yeah, I'm not gonna go into the roadmap in detail. So yeah, don't hesitate if you want to try our application, create animations, and give us feedback. I'd love to have feedbacks. Now I'm going to talk a bit more about 3D animation technology, so what we do in Kinetix and what we started with, because as I said, we're trying to make for everyone to be able to create 3D animation, and for this we chose deep learning, for generative deep learning, for everyone to be able to create animation from videos and also to modify animations the most easily possible for them. So just like so you understand that our mission is more complicated than other people. If you take like the suits company as Xsense, Rococo, Optitrack, Policis, etc. They use a suit that you can buy at home. It's like 5,000 euros, something like that. So it's too expensive for the creators in the metaverse, but and it's very complicated to use, but it's possible, and the quality is very, very good. And Move.ai, which is more like us, but they use 2 cameras. So you have to put 2 cameras with a known angle between the 2 cameras to be able to reconstruct the 3D. So what is the obvious advantage they have against us? It's that they know the depth of the man on the camera on the video, and we only have a 2D video playing, so we have no idea of the depth and of the translation in the 3D space. But they are doing an amazing job, and the quality, of course, of these guys are better than us. So just for a quick demo of the motion capture deep learning we have, it's 1 year ago. So it's we do a bit better now, but it gives you a sense of what we do. No, there's no sound. I don't think the synchronization is very good, but yeah, you can see the overall quality of our solution. So as you can see, it's okay-ish, but there's a lot of problems, obviously, because it's from just a video directly without a human touch, creating some 3D animation. So I'm going to present you, like starting from this, what are the main fields of study we have to do. Obviously, the biggest is the rotations accuracy. So how do you well predict the rotations of the animation? Also, the facial animation. That was 1 year ago. We still didn't have any facial animation. Hands animation also, same. Motion accelerations. It's slightly the same as rotation accuracy, but it's to give much more accuracy, more like to respect the philosophy of the input video. You have to respect especially the acceleration on the motions, and that's the most important thing to for the output animation to be the most more realistic. The root translation, so the translation to well respect the translation of the animation in the 3D space, which is nearly the most complicated because it's a 2D video and you have to guess how it's moving in the 3D space, so on the 2D axis and also on the depth axis, which is obviously the most complicated. And finally, the most complicated, and that no one really answered yet, is how do we respect the contacts in the output 3D animation. For example, you can see here, the only contact that matters here are the contacts of the feet, but they are not very well respected, and there's a lot of artifacts to make this, and it's very complicated. And there is only the foot contacts, but there also can be like contact from you to the table, from you to another person, and contact is really what's gonna make the animation realistic or not to someone who's gonna watch it. So this is right now our biggest field of study is how do you respect contact in a 3D animation? No. So the first thing is the architecture. It's not ours. It's a paper that was published a few months ago, I think. But we use the same philosophy in a way. That was a bird's eye viewed based coarse-to-fine localization. So how from an image you localize the different characters in a 3D space. So there are from one architecture and from one image 3 informations you need to retrieve from it: the center of mass of each person, so the root, the relative position in space of each person regarding other, which is even more important, because like if you have two people dancing together, if you don't respect the space between them, it's gonna be nonsense. And the pose of each person, so the 3D rotations of each person relative to themselves. So for example, this architecture with some 3D analysis on the image and some huge data set, obviously, create the three informations. And after this, usually you add a temporal architecture. So it depends of your taste, either CNN, LSTM, or transformers. It's more and more transformers that works better and better to produce some realistic 3D motion. But yeah, the base architecture is going to find is like something that analyzes the position and pose of every image, and then some temporal networks that's going to like take every pose and make it the most realistic possible. But the problem of this approach is it's not going to be physically realistic, because there is no contact. For example, that's the most important thing. Once again, if you take this contact between persons and contact between the person and the ground, for example, will not be respected at all, and it's going to create some weird effects in the animation. So there are two biggest methods right now to try to tackle this. The most handmade method, which is the most used, I think, in companies such as mine, is trying to first of all make a contact detection on like a real computer vision task. You have an image and you try to say where does the foot touch, which foot touch the ground. So for example, like left foot and right toe, but not right ankle. And you have this information, and then trying to make the most out of it. Also trying to have a better translation estimation with some depth estimations. There are more and more accurate depth estimation architecture, especially with the how do you call that, like automatic vehicle field, with a lot of deep learning papers that comes out of it to say we need to know where the people are in the space in real time. So thanks to this, there are more and more papers who will like take an image, take a video, and try to position people in the industry space. So there are some architectures that gives a better sense of depth estimation, and the relative rotations that was given by the previous architecture. So the first method, as I said, which is the most used, I think, nowadays, it's take these three informations and really like try your best with handmade techniques of how you can do it. But obviously the problem is like, for example, if you know at one frame your foot is touching the ground because the computer vision said so, so you're going to think I'm going to use inverse kinematics to put the foot on the ground. But if you do that, you're going to change the rotation. If you change the rotation, you're also going to change the translation. So the three are very much like working together. If you change one, you have to change the other two. So it's very complicated, and it's very like case by case. What do I do if the man is walking and I feel a contact and the foot is like 3 centimeters from the ground? Okay, I'm gonna put the foot to the ground. But what do we do if we detect a contact but the foot is like 1 meter from the ground? You won't like force the foot to go on the ground. It's gonna break the animation completely. So it's a very robust method. It's a very good method, but it doesn't solve everything at all. It's just kind of working for most of the case. The second method that is more and more used, and very recently, it's a picture of like a collision dataset, some collision networks, but it's to use a differentiable physics engine. Once again, what we want to do absolutely is to ensure our 3D animation is physically realistic. An animation is physically realistic if you can play it in a physics engine and it's just going to play without falling apart or anything. So recently, that was NVIDIA, I think, who released a differentiable physics engine whose name is I don't remember the name of it. exactly, Isaac Jim. So it's a differentiable physics engine. So you have more and more papers who are going to say, okay, we're going to put the animation into the physics engine and just like run some neural networks, but with the physics engine inside of it. So you put your animation, you check if it breaks or not. It always breaks, and then you change the parameter, see if it's like more stable or not, and you just like run it over and over until your animation is able to walk correctly. There are several problems. There are a lot of papers in last SIGGRAPH about it, but most of them like usually just tackle walking and jumping, and it's not generic at all. Like if you want to make it dance, if you want to make like a backflip or whatever, it's just going to break every time. All of the papers we've tried there could not support this complicated motions. Just because if you have a complicated data set, if you right now with the current papers, to my knowledge, every time the data set is something like too complicated or above 30 minutes of motions, it will not be able to learn a good enough way for the motion to be represented. It's especially because these techniques works perfectly for like objects, how to construct objects that are physically realistic. But for human motion, it's very complicated because there are a lot of muscles in the human body. So if you want to try this technique, you have to find a way to simply encode every muscles in the physics engine and run some learning on it. So there are some huge progress that are being made right now there, but nothing good enough. But I think, and that's on this field, we're going to start a PhD soon, is how to be able to use this physics engine to make our animation more realistic. Okay. So that was for like our biggest issue right now, which is the contact between the foot and the ground, which is like 80% of the feedbacks of our users is like the contacts are not respected, which really to state that is the most for us it's the most important thing. And also for motion capture thing, etc. It's really the thing that makes it look unrealistic. Just to show you a bit the other fun thing we do. So we also had to create the same solution but for facial animation, which is in some sense easier because there is no contact for facial animation, so it's much easier. So that's some guy who's working with us, a very intense guy. So yeah, for this we just created how do you say, a synthetic dataset of animation on facial animation, thanks to the Apple solution of facial animation, and we just made an architecture to predict the blend shapes of facial animation directly. It was not our biggest task, especially because for us the level of quality needed is not incredible. So this level of quality is appeared to be good enough for most of people. Obviously, the problem we're going to have is in this video, my colleague is very close to the camera, and you see all his face during all the video, and it's good quality. In the videos we have, they have like 10 dancers. One you can see his face. They are blurry as hell, and so there are a lot of issues. But for a good quality video, we success to have some good outputs like that. And yeah, but there's always some work to do, but for now it's good enough for us. Same for hands animation. It was the work of Theo. So same as face, it's going to be like if we succeed to do that, creating a data set with gloves, like you can buy some gloves, and that was going to recreate the 3D motion completely, and then you just film the hand moving, and you are able to recreate the 3D motion, and then you create a data set with that, and we use kind of the same architecture we used for the body to predict the it's not a real time, we just render it to predict the motion of the hands. There is just a little problems on like when you close the fist completely, there is it doesn't work very well, but apart from that, and it's it's working, and the problems is going to be the same as for facial animation. Usually in the videos, the hands, you hardly see them, they are blurry, you never know if it's a left hand or a right hand. So there's a lot of denoising to do, but hands animation for now is it's okay every time. So yeah, right now, so that was like the motion capture technology. We are trying to like deep learning motion capture technology. We are trying to improve every day for 2 years now. And the other thing we wanted to do, as I said, once again, we want everyone to be able to create animation, but also to modify animation the easiest way possible. And to modify an animation, it's very complicated because you have to play with like animation curves, and you have to be a professional animators to be able to do that. So we were wondering, how is it possible to use AI for everyone to be able to modify an animation as easily as possible? So we took great inspiration from Photoshop, where I think maybe one of the first to use AI on a global scale to like help people to create things. And they released a few years ago, I think, some thing to like make people smile. For example, you take a picture, you have a picture of someone, and you have a slider, and you say, okay, make the people smile, make his hairs grayer or whatever, make him older, make him a woman, or whatever. And they use deep learning. They use some style transfer like that. They use in-painting technology. They use a lot of basic picture deep learning architectures. They gave to the customer for them to be able to very easily modify pictures. And we wanted to take inspiration from that and wonder what can we copy in philosophy and make the same with 3D animation. So the few examples we had, for example, the first problem was the transition. So for example, if you have two animation there, one here and one here, in the middle, there's going to be like a weird transition. And like it doesn't matter how you put the two animations. Whatever you do, it's going to be a weird transition. Usually, what you can do is like saying, okay, I'm going to put a linear interpolation, a Bézier interpolation, a quadratic interpolation, whatever you want. But it's still going to seem very weird. So we wanted to use some in-painting. So in-painting, like you have an incomplete image and you like fill it in. So use some in-painting technology, but for the animation, for everyone to be able to like take two animations from a library, and then we will create automatically the good transition between both of them. It's still very much a work in progress. I don't mind this for now. Everything that I'm going to present obviously is based on how you are able to create a latent space of animation. So it's going to be some transformer autoencoder architectures, trying to build the best latent space for animation. That was the one we succeed to create recently. It's still very noisy. But if you take, so this was the base animation, and when it is like completely shrinking, and that's awful to see, it's just like when we had no, when we removed the data, and I don't know why, but the guy who made it like just put random rotations. That's why we have this this weird thing. And on the right, it was the how do you say interpolation made by our algorithm. So it's obviously not perfect. And right now our biggest problem, once again, is that when we interpolate something, we still don't have the contacts that are respected in the interpolated animations. So you have one animation with good contacts, the other animation with good contacts. In the middle, some like good animation, good rotations, but no contacts still. So there's still a lot of work to do there. Mostly because it's very complicated to create a latent space for 3D animation, like usable latent space for 3D animation. It's awfully complicated. You never know if you have to take like 5 seconds time series, 10 seconds time series, or use transformers, or it's very complicated. But it's in production for like a few weeks now, and it works quite well. Second thing we wanted to try is the style transfers thing. So just as Photoshop's making smile people, like you take a picture, you take the latent vector of smile, and you just like mix it together. and end up with someone smiling. So yeah, it's just I put some architecture there. It's usually just an autoencoder on a style embedding architecture. And we wanted to try to do the same with 3D animation. So I'm going to show you some little example we tried to do. So for example, on the background, it's someone walking, and on the not background, someone walking but old. Same as someone jumping. So it's obviously slower on everything. So it works quite well, but obviously I'm showing you what is working. So we chose 3 styles that was working: old, robot, and drunk. You're gonna see the drunk after, and also on like easy animation, like walking, jumping, running, etc. If someone does a backflip, and you ask him to be like old and drunk, it does some crazy thing. But yeah, it's useful, but also we want people to have fun. On yeah, we have some retargeting problem there. You can see the arm going into the chest. That's another problems we have to tackle. But yeah, it only works on simple things for now. And on the drunk, if people recognize themselves, the very drunk. That's not a real example. And yeah, still the drunk. So yeah.
Wait, quick question: was that a joke, or did that actually come out of the?
No, that was a joke. Sorry. And yeah, as I was saying, it's useful for people. We know in the application people use it, but it's also for people to have fun with the application. If people have fun with your applications, then got to talk about it to their friends, etc. So it's especially also for that. We know people love to try this. But as I said, for now we are continuing research on it. But it only works for drunk robots and old. Especially because it's easy to imagine what old people would walk, how drunk people would walk. Some people asked us if we can do some masculine and feminine way of animation, but it's crazy complicated, and we don't want any problem with anyone. So for now, we didn't dare to do it. A last how to say. Inspiration we wanted to take is how to create animation automatically. So if you take the amazing DALL-E from Google, right, where you can just put any sentence and it creates some images. Usually the problems with it's very funny, but usually the pictures are not very beautiful. But we wanted to be able for people to have the same kind of fun with animation, put some sentence, put some music and everything, and for it to create animation automatically out of it. So what we ended up doing, that's my favorite video, is people put a music and we make the animation dance automatically on the music. So if there are some French people in the room, they are going to recognize the music. If no, I'm sorry. So it's we got a moving camera for it to be more clip-worthy. The most complicated is to respect the rhythm of the music, and obviously it's not fully generated. It's over trained on a dance database, and then you just apply the rhythm on the dance database for it to respect the rhythm. Every time. Up. So if any of you have any other fun ideas of how we can make people modify animation, create animations on crazy ideas like that, I'm very open to it. Thank you for listening, and if you have any questions.
Thanks, Henri. Really nice presentation.
Thank you.
Excited, actually, very enjoyed it.
If you
Anybody wants to start with questions?
Yeah.
We talked about creating animations and moving them to virtual environments.
We are working in real time. It also depends what you're seeking with real time. Is it like a 0-second latency, which is possible, but you're going to decrease the quality terribly, or if you can allow yourself like 0.2, 0.5 seconds of latency, and if you allow yourself at least 0.2 seconds, so you can see a bit in the future of the animation to run some temporal architecture. It is possible, and some people are working on it. We are working on it too. And also for the UX of the application, because for now you put your video and you have to wait like 1 minute to have your results, so it's not very UX friendly. So we are working on real time also for this year. Oh.
Thank you for the presentation. Very nice work, really. One question: are you aware, or do you think in the future, like you will be able to use these methods, for example, to create or to generate new synthetic data, like, you know, for example, for deep learning approaches, like in order to have more amount of data and therefore also like better learning-based approaches for character animation? Do you think could be plausible to use this?
Like, you mean create a 3D animation and then use it as a data set?
Yeah, exactly, to have more data.
What is possible is like you can create some random animation, some random realistic animation, and then use some 3D software's script to like put a random camera and put some random characters, put some random textures, so like render a 3D scene automatically out of it, and then like film it. So automatically what you can end up with is a video and the corresponding 3D. So this is very possible, and this is what a lot of people do, yeah.
Okay, cool, thank you.
My question was to say, if you were going to implement like reinforcement learning to the data that people generate by using your...
Oh.
I don't know if you heard the first part.
Yeah, I heard the first one. That's obviously our long-term dream, but what's complicated is when people upload a video, we create a 3D animation, but we don't have any ground truth of it, so it's very complicated for us to make something out of it, even with reinforcement learning. It's very complicated. What we'd like to do right now is allow the customers to say, okay, that was a good animation, or no, that was terrible as hell. And then the bad animation, we can like go to them manually, having our like animators correct them manually, and then retrain on them directly. But not on an automatic pipeline, it seems very complicated for now.
Thank you.
Thank you. I have one more business-oriented question. So I'm a PhD in computer vision. I actually come out of the group that you used some of the research
cool.
that we produced, or the people before me. I saw the simple body model. So Michael Black, my advisor, would be very happy to see this because, yeah, it's one of his babies, quote unquote. My question is, you use a lot of machine learning. In research, we care less about licensing because it's just data from the internet. We can use it for the papers. But then ultimately, if we wanted to create a product with it, then it's not for free anymore. How do you get around this? Do you gather your own data, or do you just pay a lot of money to whoever designed the data set?
Yeah, a very good question. Not my favorite. Yeah, obviously, I know Michael Black. I talked to him once. His research, so your research, are really incredible for this field. Obviously, when we first started 2 years ago, Kinetix, we took some papers and we just show it to people without selling it. So that was allowed back then because we are not selling anything, we are not doing anything. So that's why I would advise anyone who's creating a company is like don't restrain yourself from doing that. You are allowed to do that. Just show to investors, show to customers, look what the academic research is capable to do. But then, obviously, when you create a product out of it, when you're trying to make money out of it, we don't. Right now, it's all free, so we don't make money, but still. You have to retrain your architectures. You have to use your own data sets. So all the architectures we use are obviously inspired by people. We don't do like... we didn't do 10 years research, so it's obviously inspired, but we had to change it. We had to retrain it on our own data for legal reasons and also for performance reasons and to make it more robust. Yeah.
All right, thanks. One more note. I saw some of the stuff that you work on. I have a bunch of colleagues that are working on similar things. They're working for their PhDs. If you want me to put you in touch with them, there might be some interesting discussions happening.
I'd love to, yeah.
Okay, then we connect after.
Thanks.
Yeah, we still have some time before the next talk is 4 o'clock. So if anybody else wants to ask. No?
Could be a stupid question. Thank you. It looked really cool. So when you were explaining like the part where you first in the video you have to kind of find the person and then then everything after that, and then I was wondering, so when you have found the person and you have like matched the 3D model to the person, then like could you ask people to do like a starting neutral, I don't know, T-pose or whatever, and so that your system knows, okay, here is the floor, so you then know based on the model that you match to the people that this is the ground plane, and you have the people standing, and I don't know, do stuff with colliders, and because now that you have the model, you know that the person can only move like in a certain way, and I don't know, and save some of the other very complicated things that come after that.
Yeah, something like that could be done. That would help us a lot if like you put a rule like to measure distance on the video. That would help us a lot. That would help us a lot if people were starting in a T-pose like that also, or if we knew the height of people. So there was a lot of information we could ask people prior to putting the video in our algorithm. But we also want people to be able to put like YouTube videos, because not everyone wants to do a backflip to have a backflip animation. So we restrain ourselves not to ask anything or to ask a minimum amount of things. Maybe at some point we are wondering if we can ask when it's possible the how do you call it, camera informations, because the depth estimation would be much easier if you knew what camera you're dealing with. Maybe we're going to ask this, and also on our like web application, phone application, because if you do it on a phone application and if it's fielding like that, you're going to know this information of the camera. So we might ask this information in the future when it's available, but we restrain ourselves to ask much more because it's complicated.
Yeah, makes sense. Thank you.
So in the demo you showed to us, like the user could choose different characters for the animation, right? So for the retargeting process, like what if like the character have the self-penetration problem? Like is it possible to do post-processing to correct it, or
to post-process in another software or in our software?
In your software.
Oh no, it's not possible to post-process manually something, because we don't want any task to be technically complicated. Okay. We do have some self-penetration problems, as you have seen, but most, like all the characters we provide in our library, we know their architecture, we know their skeletons, so there are no big retargeting problems. They still have some little self-penetration problems when the like mesh is huge and there is like a motion that should not be possible. So we're trying to tackle this, but no, there's no post-processing.
Okay. Thank you.
Great work. Thank you very much. I was just wondering if you could tell us a little bit more about your business model, or how you plan to make money with this. If there's anything you can.
Yeah, at some point we have to think about it. Yeah, for now everything's free. So we raised some money recently to be able to like have 40 people and having a completely free software that use a lot of cloud resources. But yeah, at some point we tried the monthly subscription business model. Like you pay us 30 euros per month and you can freely use the product. It had very little success. It was 1.5 years ago, but it had very little success, and that's when we shifted to the metaverse. And right now we are more wondering about how do you call that, marketplace, 3D marketplace animation. So we want everyone to who want animation in the metaverse to have to go by us in an NFT model. So what's cool about the NFT models is you're gonna have the creators who are gonna create the animation, put it on the marketplace. It doesn't have to be only on our marketplace, by the way. It can be on several NFT marketplace. And then the users is gonna either just use the animation from our marketplace, and then with the NFT technology, the creator is going to receive a fee out of it. We're going to receive a fee out of it, and you're going to be able to use it. You also can use this NFT and like combine it with other NFTs, create some other NFTs on our tool, and everyone is going to receive a fee. But yeah, it's going to be more marketplace-based business model.
Yeah, when you said you need people to have fun to make money eventually, so continuing with the money question. But my question is more, how do you get user feedback? How do you make sure people have fun?
It's always complicated when you're a B2C, so a business to customer, to have user feedback, because you don't have 10 customers, you have like 30,000 for us, 30,000, nearly 40,000 now. We have to call them. Actually, there's no really other way. We have some forms they can fill, but usually they just type whatever they want. So to have like real answers, you need to have a product guy in your company that's gonna like call 50 people and asking them what was wrong, what was good, what do they want. And it's always complicated to ask a customer what do they want, because they don't have a clear idea of what features they want, obviously, or else it would be too easy. But yeah, we don't see other ways of like just taking inspiration from others, like Photoshop, and just asking people. And that's also why we hired 4 3D animators, 4 professional 3D animators, who knows what an animator would need, and we can ask them some product UX related questions.
It's 400, so thank you very much.
Thank you.
Yeah, I will do this.